All right. All right. Today's video is specifically a video about what a series circuit is. Now, we've already looked at things like this in previous videos and essentially know that what's happening in this simple, most basic circuit is you've got electrons. So if we want to think of it, a flow of electrons that are leaving from this, we'll call it a battery, from this potential. So these electrons, let's just follow through the circuit. What's going to happen? Here comes the electrons. And this flow of the electrons, if you can imagine this group of electrons, here we come, here we come. This flow of electrons, it's got a term. That's what we refer to as I, and that's what's known as current, and we measure that in amps, and an amp is nothing but a coulomb per second. If you remember previously, we've talked about like an electron itself. An electron has a charge of 1.6 times 10 to the negative 19 coulombs. So if we were to go back and let's say look at a problem and say that you had 1 amp of electricity, that means you've got 1 coulomb per second of charge flowing through that wire. So hopefully you get the idea that that's a lot of electrons. If you've got 1 amp, that is an awful lot of electrons that we're actually referring to here. So anyway, let's take a little bit further of a look at this as I completely mark up my screen here. Anyway, so we know what's going to happen. The electrons are going to flow. They're going to go through this resistor, go around, and the goal is the electrons come back. And so that's what we have to have this complete circuit like we have in here. So if we remember this battery or this power supports this is what we refer to as a potential. Let's say that you've got like a potential of 9 volts. And so this potential is literally telling you this thing's ability to push these electrons through the circuit. And so the wire is a conductor. So the wire isn't holding against it. So what is it that's actually holding back against, what's actually holding back the flow of these electrons? Well, that's this resistor down here. And so this resistor, the way we usually look at it, it's almost like a clogged pipe. And I think that's why we probably go with this symbology of the little squiggly line. But it's hard for these electrons to get through this resistor. So this resistor is holding back against it. And so resistance is usually measured in something with an ohms, and that tells us the value of that resistance. So if we went back to Ohm's law, we know our primary values is that we know that potential is equal to current times resistance in ohms. So this is our foundation. What's funny, electricity problems are kind of easy in the sense that, you primarily use this formula for the bulk of all the work you do. Now, today's video is talking about what makes a series circuit. So I'm going to scroll down and see if I can get another picture in here. And I'm also going to grab hold and move this meter out of the way that just happens to be floating around on my screen. So let's take a look here. So this is what we would refer to as a basic series. Again, the word of the video today is a basic series problem, because what's going to happen again is the electricity is going to do what? The electricity, the electrons, the flow leaves this battery, and as it goes, leaves the battery, here it comes. And so remember, this is what we refer to as the current, the actual flow of charge. And it goes, and the electrons have to get through this resistor, so that we've called R1. And then they also have to go, if they keep going through this other resistor that we've called R2. They'll leave, and eventually all the electrons will do what? They will eventually keep working their way, and all the electrons will return back to the other side of our potential here. So as we look at this video, how do these work? All right, there's 3 formulas that we kind of need in order to solve this problem out. So I'm going to write one of my formulas. I'm going to say this. I'm going to say that the current total in this circuit, and depending on how you look, different books, some books will say this, they'll say like I with an EQ or equivalent, and some will say I total. For the purpose of this video, I'm going to go with the designation of like this I total. So anyway, one of our formulas that I'm going to write is this. I'm going to say that I total, in other words, the current leaving the battery. So over here, here's the current leaving this battery. Well, this is interesting. A lot of times a problem will ask you, well, how much current is flowing through? Let's call it I1. How much current is flowing through resistor ones? Well, look, remember, this is like water flowing through a pipe. All of the electricity leaving this power source is doing what? It's still flowing through R1, which means that the total current has got to be equal to the current in I1, and then that leaves here and it flows. So how much current, we'll call it I2, is flowing through resistor 2? Well, it's the same piece of pipe that we've got here. So all the current is the same. And so likewise, let's just say that, let's scroll down and just look at it for a second. Let's say it was this problem where we've got 3 resistors. What could we say would be true about the current I1, the current I2, and the current I3, at least when we compare that to the current, I'll say the current total that's leaving our battery? Well, they've got to all be equal to each other. So they're all going to be equal to each other. So I saw a little second ago, I had like a meter floating around here. So let's say we had a digital multimeter, and I'm going to put a mark across it because that's what I like to do. Let's say we could take that meter and bring it down, and we could place it in this circuit. So let's say we brought it and placed it here. Now to do that, we would have to cut the wire right here. So we would actually have to, this meter would become in series with the resistor. What we would find when we powered this up is that this ammeter would read the same here. And then if we brought it over here, it would also, once again, the reading would be the exact same reading because it's the same current. If we could bring it anywhere in the circuit and cut the circuit, we would be able to find that the current was the same anywhere inside there. So we got a little basic of an idea. Another ungroup my, go away ammeter, I no longer need you. All right, so we've got about 3 formulas. We're not going to work anything in this video. We're just trying to get the fundamentals. The other thing is this. What about the resistance? So how about the resistance total? So if we look at the resistance, what we would find is this. The total resistance in the circuit. And again, some textbooks will use this, like REQ, the equivalent resistance. I've even seen some textbooks, they refer to this as like RT, which I admit is shorter than R total, but I'm just going to continue to write this R total. But R total is, now you got to think of it. Each of these resistors are combining together to work against that flow of electrons. So the formula itself is actually a really simple formula. We would just say it's R1 plus R2. And for that matter, if we were looking at this other circuit down here that had the R3 in it, then we would just also write is equal to R3. So all those resistances combine to work against the flow of electricity. Now there's one term left. So what about the voltage? So let's say our voltage total, let's say, is over here to the side. And let's say that we had what? Let's say we had a 9-volt potential in the circuit. Here's what I would know. Each one of these resistors, so say this one, if we would take a meter and we would measure a voltage across this, if we would measure the potential across this, and this would be an easy thing to experiment with and do in the lab, would be to build a simple circuit just like this, and then take a voltmeter, similar to like this one that I just drew an ink mark across. Would be to take a voltmeter like this one, and literally what you would do is literally just place the voltmeter across the resistors, and what you would find out is when you would go through and measure those potentials, you would find out something interesting. All those potentials would combine. Let's say, for example, if it was like this one up here that had the 9 volt on it that we looked at earlier, all of the potentials would combine to make 9 volts. And so what you would also find now is this. So our formula would be V1 plus V2 plus, here we'll say V3, would all equal to V total. And we could have R3, R4, R5, and we could just keep going with the resistors out through here, and this would still hold true in here. And what you would find is this: the biggest resistors would also correspond to the largest potentials. Because if you want to think of it, let's say, for example, let's say that we had a 10 ohm resistor, a 20 ohm resistor, and let's say that the last one was a 30 ohm resistor. Which one of the 3 resistors should be the hardest for this battery to push the electrons through? Well, obviously, the 30 ohm resistor should be the hardest to get the current through, so we would have the greatest potential present over this resistor. And for that matter, it would be the 10 ohm resistor. So a good test question would be to simply give you a picture like this and literally ask you to rank, maybe give you these resistors and rank them in order of which ones would have the greatest to the least potential across there. And likewise, a nice little trick question then would be to say, well, rank them in order of which one would have the greatest current flow. And of course, which one would have the greatest current flow? Well, obviously, again, they're all equal. A series circuit literally means there is no opportunity to branch this out. I'm going to do one thing, and then we're going to stop this video, short video. What I want you to do is this. So as we take a look at this video, here is a basic parallel circuit. And if you notice, what's different in the circuit is that when the current flow gets to this position, and we call this a junction, this spot where they run into each other, we call that a junction. When the current reaches that junction, what's it going to do? It's like a split in a pipe. And so you'd have part of the current flowing through R1 and part of the current through R2. So this is your fundamental difference between a series and a parallel resistor. So just be on the eye for those junctions, and we'll talk about the junctions in another video.